This is section 10.2, graphing quadratic functions in standard form. We're moving now to normal quadratic functions where you have an a squared term, a bx, and a c. To find the axis of symmetry when graphing, you have to calculate the x-coordinate of the vertex, and you do it with this formula. The vertex equals negative b over 2a, where b is the coefficient of the x term, and a is the coefficient of the x squared term. Once you've found the x-coordinate of the vertex, you find the y value by substituting it back into the original equation. You can also find the y-intercept of a parabola by looking at the c term in the equation. Parabolas have a y-intercept of c, so the point 0, c is on the parabola. So you can calculate both the x-coordinate of the vertex, the y-coordinate of the vertex, and then the y-intercept of the parabola, and then you can rough out the parabola. This is a general drawing of a parabola, y equals ax squared plus bx plus c. In this case, a is greater than 0, so we know the parabola opens up. The x-coordinate of the vertex is negative b over 2a. That will be the minimum of the parabola. And then it crosses the y-axis at 0, c. So I've plotted those points, and that's the general shape of the parabola. Let's find the axis of symmetry in the vertex for this equation. Y equals negative 2x squared plus 12x minus 7. Well, first you look at it and you see the coefficient before the x squared term is negative. That means the parabola is going to open down. So when we calculate the vertex, it will be the maximum or the highest point of the parabola. We can calculate the axis of symmetry, or the x-coordinate of the vertex, by using negative b over 2a. In this case, it's negative 12 over 2 times negative 2. That's 12 divided by 4, or 3. This is the axis of symmetry. This is the line that runs vertically through the middle of the parabola, dividing it in half. So x equals 3. You can drop a dashed line down the middle of your coordinate plane. But because we only know the x-coordinate of the vertex, we now have to calculate the y-coordinate of the vertex to know exactly where the point is. You're going to substitute it back into the original equation. So we take the 3 that we just calculated and put it back in the original equation as shown on the bottom line. Y equals negative 2 times 3 squared plus 12 times 3 minus 7. That equals 11. So the y-coordinate of the vertex is 11. We now know both coordinates of the vertex, 3 and 11. Now you can graph the parabola. If you know the vertex is 3, 11, and you know that it opens down, you also know that the y-intercept is negative 7. That's the c value. So we're going to rough it in here. I plotted my points 3, 11. That's the maximum. And then I made a cross at negative 7. The pink line dropping down the middle is the axis of symmetry, so we know the parabola is going to be the same on the left and right side of that line, and then you can rough in the shape. The key here to know is that if a parabola is opening up, the vertex is always going to be the minimum or the lowest point of the parabola. If the parabola opens down, the vertex is the maximum or the highest point of the parabola. Look at these two equations below. You should know by just looking at them if they have minimums or maximums. The first one, y equals negative 3x squared minus 12x plus 10. We know a lot of things about this parabola before we even plot any points. Because the coefficient before x squared is negative, we know that the parabola opens down. We also know that it's going to cross the y-axis at 10. In the second parabola, the coefficient of the x squared term is a positive 4. That means the parabola is going to open up, and it's going to have a minimum point as its vertex, it will be crossing the y-axis at -8. So the first parabola, because it opens down, will have a maximum, and the second parabola, because it opens up, will have a minimum as its vertex. You should be able to calculate these points by using -b divided by 2a to first get the x-coordinate of the vertex, then plug it in and get the y-coordinate of the vertex.